Up is asking if each of these is a function or not. And in order to determine if something is a function, all you do is look at the x's and make sure none of them repeat. Because all of these x values are different, this is a function because no x's repeat. In the second example, the 5 is repeated, and so this is not a function. So x equals 5 is repeated. And this next one is just pretending letters are graphs and seeing if they pass the vertical line test. And so some examples of letters that would pass is like a V or a W. Let me do a better W. It's got to be really slanted, because if I were to do vertical lines, I don't hit the graph more than once. Okay, so each of these would pass. You could also make the M pass if you do it slanted enough. Same with N. You could also make U pass. But letters that don't pass are like S, O, T. If I were to do a vertical line, I hit the graph 3 times. That's not good. For the O, oops, I hit the graph 2 times. Gosh. And then for any letter that has a vertical line definitely fails. And so both of those, all 3 of those would fail. Okay, and so that's how you determine if something's a function or not. If you have ordered pairs, just make sure x's aren't repeated. If you have a graph, make sure it passes the vertical line test. And so there's a lot of vocabulary here, but the main thing we're after today is domain and range. So domain is all your x's, it's all your inputs. Whereas range is all your y's, it's all your outputs. Okay, and so if you have ordered pairs, your domain is always going to be the first numbers in the ordered pairs, and your range is going to be the second number. And so it's alphabetical order. D comes before R, X comes before Y, D before R, X before Y, I before O, first coordinate before the second coordinate. So when in doubt, alphabetical order. And so I'm going to skip to some examples. Okay, and so if you have a set of ordered pairs and you're trying to find the domain, your domain is your X, so you circle the first number in each ordered pair. And we use squiggly brackets and then just list those in order from least to greatest. And so that would be your domain. And then your range would be the second coordinate, your Y values. And if you see a value repeated, don't write it twice. So like the 1 is repeated, but just like if I were to see a student twice, I wouldn't put them on my roster twice, because then it looks like I have extra students. And so you would just do 1, 2, 3. If it's a table, it's even easier because they're all lined up for you. So here's your domain. And so we would have -2, 0, 1. Don't repeat the 1. Then 3, squiggly bracket. -2, 0, 1, 3. And then for the range, it's the Y's. But just be careful because they didn't put them in order. So we're going to do the -2 first. And then the -1. And then the 3, then the 5, and then the 7. So in order, don't repeat values. The mapping is even easier because they don't repeat values already and they put them in order. So you just have to know that X is the left and it gets mapped to the outputs, which are y. And so your domain is 0, 1, 2, 3. And then your range is 2, 3, 4, and 5. The graph is probably the hardest. And so whenever you have a graph, if they don't label the axes, go ahead and label them. So this would be 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. And so when you're labeling your points, make sure you look at the x-axis before the y-axis. So this point right here is 0 on the x, but 1 on the y. And so 0, 1. This point is 1 on the x, 3 on the y. And then this last point is 2 on the x, 5 on the y. This point down here is -1, -1, -2, -3. Nope. And then this last one, -3, -5. All right, and so once they're labeled, we are ready. Domain is x. And so go from left to right, -3, -2, -1, 0, 1, 2. And then for range, go from bottom to top, so they'll be in order. -5, -3, -1, 1, 3, 5. All right. And so all of these 4 examples are all examples of discrete functions or relations. And discrete just means they're disconnected. Basically just isolated points. And so in each example, we just have 1, 2, 3, 4 points. We have a table of isolated points. We have a mapping of isolated points. We have a graph of isolated points. If these were connected, we would call this continuous. And so these next 3 examples are all continuous examples. And continuous in math doesn't mean it keeps going. It means it's connected. It means you can draw it without picking up your pencil. So in each case, I don't have to pick up my pencil to draw this. I can draw this, I can draw this. Whereas here, I had to pick up my pencil each time. And so that's why this example would be a discrete graph, whereas all of these would be considered continuous. So discrete just means disconnected. Continuous just means connected. And so I remember it because it's discrete, disconnected. And then this is continuous, connected. Okay, and so the reason why we care about that is because we can't list our points with a continuous graph. So let's look at this one first. I could list -3 as an x value. I could list 1 as an x value, but we have infinitely many points in between when it's connected. We have all the decimals. And so I would have to list 0.5. I would have to list 0.9 repeating. And so there's an infinite number of points on a continuous graph, a connected graph. And so we switch our notation. Okay, and so for domain, it's still your x. And so you're going to put an x right in the middle, and you're going to put an inequality sign, a less than sign on each side. You're always going to use the less than inequalities. You're never going to use the greater than. You're going to hear me say over and over again, alligators eat to the right. They always face to the right. They always eat to the right, because we're going to write our lowest x and then our highest x. So we want the highest value here. So highest x, lowest x. Okay, and so some people like these better than the discrete graphs because you don't have to list a bunch, you just list the lowest and the highest. And so for range, it's similar, only you're going to put a y. Alligators eat to the right. And then you're going to put your lowest y and your highest y. And so for me, it's easier to think about putting the function in a box. So switching back to domain, let me get pink. A little bit bigger. The sides of my box, if I were to put this function in a box, I'd put the left side right here at x equals -3. I wouldn't want to go way out to -5, because if I were shipping this function in a box, I don't want room here, because then it's going to move around, it's going to get broken. I also don't want to chop off the function anywhere, and so you want to put it right on the edge at -3. And then the right side of my box would be here at x equals 1. Okay, and so you want to put -3 here, +1 here. Okay, and then the last thing you have to ask yourself is, do either of these inequalities need a line? And so if they take the time to fill in the circle, you're going to put a line. You're going to take the time to draw the line. At the -3, they did not take the time to draw the line, so we're not going to take the time to draw, not line. They didn't take the time to fill in the circle, and so we're not going to take the time to draw the line. And so what a lot of students get confused about is if there's not an open circle, it's automatically a closed circle. So we could put closed circles here, 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 here. And so just be careful for the open circles. As long as it's not open, you can draw the line. So that comes up on the range. So for domain, we're looking for the left side of the box. And then for the highest, we're looking for the right side of the box. When we're dealing with range, we're looking for the bottom of the box and the top of the box. Okay, so the bottom of the box would be here at -3, and then the top of the box would be here at +3. Notice I'm highlighting y values on the y-axis because this is range. So the range goes from -3 to 3. So -3 to 3. And because there aren't open circles here, it's automatically closed. Same here, automatically closed. And so we're going to need lines under both of these. Oops. Okay, on this next one, same idea. When the question is asking for domain, cross off any option that doesn't have x. And then if it's asking for range, cross off any option that doesn't have y. And so switching back to domain, we want the left and right side of our box. And so the left side of this box would be here at -3. And then when I try to put a right side of the box, there's an arrow here. And so whenever there's an arrow, it's going to bust through the side of the box. And so you actually can't put that side there. that means it's going to keep going. So you can't box it in. It's going to positive infinity. And so you would put positive infinity here. If it was going to the left, you would say negative infinity. But for the right side, it's positive infinity. Okay, and so we have an open circle at this -3, so we're not going to draw the line. And then infinities will never get the line. So I made that note that infinity and negative infinity never get a line. Because you can't equal infinity, it's a direction, not a number. So because you can't equal it, you can't put the line here. Okay, and then for range, we're looking for the bottom of the box. And it would never bust through the -2, so we can put that bottom of the box here because it's going to the right, not down. And then here at +2 would be the top of the box. So the only side we can't have is the right side. So I can put -2 here, +2 here. And then there's not an open circle here, so I need the line at +2, but there is an open circle here at the -2, so we're going to leave that one open. Okay, and for this last one, same thing. Domain, you're looking for the x's. And then for range, you're looking for the y's. Okay, and so if I try to put the side of my box here, you still can, even though they stopped the graph, there's an arrow. So it is going to keep going to the left forever. So we would have negative infinity to the left. And then if I try to put the right side of the box, it would keep going to positive infinity. Okay, and so arrows mean infinity, and we can't put the line under it. And so that's the same thing as saying all real numbers. Anytime you go from negative infinity to positive infinity, that's the whole number line. So all real numbers. Or you could use a fancy R with 2 lines and make the R from the back line. That means all real numbers. The lazy mathematician way of saying that. And then for range, it's the same idea. If I try to put the bottom of the box, this function is going down forever. And if I try to put the top of the box up here, it's going up forever. And so negative infinity, oops, that's an 8. Negative infinity to positive infinity, or all real numbers. Anytime you have a line like that with arrows, it's going to be all real numbers for domain and range. And then the last thing we're going to talk about is when you have a word problem, they're going to ask you for what we call an appropriate domain and range, or a reasonable domain and range. Because anytime you're dealing with real life, some numbers aren't going to make sense. And so that's why they say reasonable. And so in order to figure out a reasonable domain, you have to know what x represents, so you can figure out what the reasonable domain would be. And then you have to figure out what y represents to know a reasonable range. And so that's the hardest part. And so here's a trick. I'm going to read this problem first. Test is worth a total of 100 points. Each time a problem is missed, the student loses 10 points. Assume the test is multiple choice with no partial credit. Okay, and so when you're trying to decide what x and y are, look for some kind of rate. And so this sentence right here is telling me he loses 10 points per problem. Okay, so you're looking for words that say per, because if you can find the word per or make a sentence that has per in it, it's always going to be y first. Y per x. Y per x. And so that automatically tells you what y represents, points, and it tells you that x represents problems. And so if I wanted to make a table, I would put problems here, and I would put points here. And you want to make sure that your right column depends on your left column. Y should always depend on x. So how many points you earn on a test depends on how many problems you missed. Okay, and so if I miss 0 problems, I would earn a 100. I would still have all 100 points. If I missed 1 problem, I would have a 90 because it's 10 points per problem. If I missed 2, I would have an 80. If I missed 3 problems, I would have a 70. And in order to get a 0 on the test, I would have to miss 10 problems. And then that's everything we need to be able to figure out the domain. So a reasonable domain would be 0 problems, 1 problem, 2 problem, 3 problem, all the way to 10 problems. It doesn't make sense to miss more than 10 because then I would have a negative score. And so this would be the reasonable domain. An option on the test would have 0 to 10 using inequalities. You don't want to pick that choice. Whenever you use inequalities, this includes decimals. Includes all the numbers between 0 and 10. So 1.5, 2.7, 3.9 repeating. And so since that doesn't make sense for problems on a test with no partial credit, we have what's called discrete data. Only whole numbers make sense. Okay, so anytime only whole numbers make sense, it's going to be discrete. And so examples would include like any kind of object, people, t-shirts, things where you wouldn't have like half a t-shirt that you're selling or half a person. And so anytime you have objects, people, things you only want whole numbers for, your data's discrete, and you want to have it listed in squiggly brackets, not inequalities. And so same thing for the range. The only numbers that make sense for our range are 0, 10, 20, 30, all the way to 100. Okay, if each problem is 10 points, there's no way to get a 5 on the test. There's no way to get a 95 on the test or a 73 because there's no partial credit. And so these are the only numbers that would be my outputs. They are the only ones I would have in my range column. Okay, the next one is similar, but this time we're going to be able to have decimals. And so it says a car is traveling at a rate of 70 miles per hour for 5 hours. Okay, so that tells me y per x. And so x is hours, y is miles. Okay, and so if I were to make a table to organize this, I would have hours here, and I would have miles here. How many miles I've driven depends on how many hours I've been driving. Okay, and so I can't drive negative hours, so we're going to start at 0. And if I drive for 0 hours, I've gone 0 miles. If I've driven for 1 hour, since I'm going 70 miles per hour, I'm going to have gone 70 miles in 1 hour. And then I can figure out 2 hours. I would now have 140. And then 3, 4, 5, because I'm only driving for 5 hours. They limited me here. And so I would have 210, 280, 350. Okay, and so when I'm dealing with domain, I want to talk about the hours, which is going from 0 to 5. Yeah, keep talking. You can talk. Yeah, that's okay. So for domain, we would want the decimals this time, because we can have half an hour, we can have 1 minute, we can have 2 minutes. And then one of the options is going to be 0, 1, 2, 3, 4, 5. This time you wouldn't want to pick that one, because decimals make sense for time. Decimals are allowed. Okay, so this is continuous data, because decimals make sense. Time is continuous. So anytime you're dealing with time or something like volume or distance, you don't just have whole numbers. You can have half an hour. You can have, half a gallon or half a mile. You can have a quarter of a mile. You have all the values in between. And so same thing for the range. You're going to go from 0 to 350. And so usually these are multiple choice, and you'll be able to narrow it down by knowing what X and Y represent, and then knowing if it's discrete or continuous. If you can answer those 2 questions, you can narrow it down to the correct answer.